Let's take a look at some exam questions regarding the complex plane and the representation of complex numbers in the polar form. The first question is this one, question 8 from Spring 2015, paper 31. It says the complex number W is defined by W equals 22 plus 4i over 2 minus I, the whole thing squared. Without using a calculator, show that W equals 2 plus 4i. Let's take care of that first. So first thing you have to do is to expand this. From here to here, I already did the two things at a time. I expanded it, and this is going to be 4 plus 2 times minus I plus I squared. I squared is minus 1, so I already put that over here. And this is the second term that I just mentioned. I kept the numerator the same. Now I simplify this. And basically, now you have to divide this complex number by that one. You already know how to do that. You just multiply by the complex conjugate of this on both numerator and denominator. So now you take care of this multiplication. Here you have it. Take care of this, or you should know already that this result is always 3 squared plus 4 squared. Okay, the other two terms are going to cancel each other. And eventually you have this, divide real part 50 by 25. For the imaginary part, divide 100 by 25, and here you have it. Now, it is given that p is a real number such that pi over 4, the argument of w plus p is comprehended between and including pi over 4 and 3 pi over 4. Find the set of possible values of p. Okay, let's substitute w by what it is. We already know what it is. Okay, so it's this. So let's just represent this in an Argand diagram. So the complex number in question is going to be minus 2 minus 4i. Don't forget that this should be a minus, all right? So if you put there a minus, then the complex number is going to be minus 2 minus 4i. Just put it over there. And now you know that the argument of this should be comprehended between minus pi over 4 and 3 pi over 4. This is always measured against a straight horizontal line that passes through the point of reference, which is this one. Okay, so pi over 4 is 45 degrees. 3 pi over 4 is 135 degrees. So here you have them. And now pay attention to one very important detail. It says here that this is not the one. It is given that p is a real number. So if it is a real number, it shall be on the real axis. So the points that you want are these, and you can get this with the Argand diagram, all right? Why? Well, you know that this is supposed to be, the size of this is supposed to be 4, right? You know the size of this is supposed to be, the size of this is 2. But more importantly, you know that this is pi over 4, which is 45 degrees, okay? So if you have a line that starts over here and makes a 45-degree angle, eventually it will cross the x-axis in a way that this makes a triangle that has these two sides with the same size. So if this is 4, this is supposed to be 4 as well, because this is 45 degrees, right? So if this starts at minus 2 plus 4 is 2. For this one, this is 135 degrees, okay? So acts exactly the same way. If this is 2 of size, this shall be also 2 of size, so, but on the left, to the left. So minus 2 minus 4 is minus 6. Any point in between these two is the point that you want, point P. Don't forget that what you have here, I didn't do it, otherwise it would be too confusing. This is a region where the point P may be, okay? The only points that are real are the ones that are within this line, that lie again between minus 6 and 2. Okay? Question 3. The complex conjugate of W is denoted by W star. The complex numbers W and W star are represented in an Argand diagram by the points S and T respectively. Find, in the form of modulus of Z minus A equals K, the equation of the circle passing through S, T, and the origin. Okay, it almost goes without noticing, but this point is important. It passes through the origin. So let's go and represent what we know in an Argand diagram to begin with. So if W is 2 plus 4i, the complex conjugate is going to be 2 minus 4i. So let's plot them. This is going to be S, this is going to be T. And you also know that you will have a point, or the origin itself is going to be part of this circle. You know that you have a circle, right? And the equation of a circle actually is given on the question itself. Where am I? I've lost myself where I'm supposed to be. I was again in a wrong paper. This is it. This represents the equation of a line with center A and radius K. Okay? But if you know that these points must belong to the circle, so there's something else you know. You know that the center must be such that the distance from the center to the origin is equal to the radius of the circle. In other words, the point of reference that you want is going to be lying on the real axis, so it's going to have just a real component, right? And the radius has magnitude the same as this distance over here. And just by using trigonometry, you can get everything that you want. In the first you know that the values that you have here, this value A and this value K, shall be the same, okay? This is the point of reference, the center, and this is the radius. And as I just told you, one and the other, they are the same. This distance is the same as that. All right, so I just go ahead and I put the same letter over there. And now just use trigonometry. What do you know? You know that you will have this rectangle triangle in which the radius is the hypotenuse, right? And if you use Pythagoras, you know that SC squared is going to be equal to AS squared plus AC squared. What is AS squared? AS squared is this, is 4, right? What is AC? AC is just OC, which is the radius that you want, is C, minus OA. And OA, you also know what it is 2. Okay? So we can go ahead and substitute everything. Here, OC, I just represented by the letter C, the one that we want. So this is going just to be C squared equals 4 squared, which is 16, plus OC, which is also C, minus 2, the whole thing squared. And then you just have to solve this equation. You solve the equation, and you have the value of C equals 5. So the equation is going to be Z minus 5, the modulus of this, equals 5. The tricky part of this question was to figure this out, okay? But with the help of the diagram, this should eventually be clear. So that's that's why you should practice and spend some time doing Argand diagrams to the best of your ability, so that these things become clear once you look at them. Next question, June 2009, paper 3. And question is question 7. Solve the equation z squared plus 2 square root of 3iz minus 4 equals 0, giving your answers in the form x plus y iy, where x and y are real. Okay, let's do that first. Okay, so you can solve this as a quadratic because, in fact, it is a quadratic. Solve it for z. I just applied here the quadratic formula. B squared is this. Okay, so if you square the whole thing, this is going to be 4 times 3 times I squared, which is minus 1. All right, so this is just going to be minus 12, and this is 16. Okay, so this is the square root of 4, which is 2, and then you just take care of this, and the real part is going to be this. You have the minus 2 over 2, which is minus 1, minus square root of 3i, and you also have the plus 2 over 2, which is just 1, minus square root of 3y. So here you have the two answers. Sketch an Argand diagram showing the points representing the roots. It's just one point because it's very simple to represent. Here you have the 2 points. Then find the modulus and argument of each root. The modulus shall be the same, that is a distance to the origin. Okay, so square root of 1 squared plus either one of them. It's minus square root of 3 squared, and this is 2. And the argument of, which one I did first? I did for this, is 10 negative 1 of this over that. But this lies, as you can see here, on the third quadrant. So what is the thing that you have to do? Whatever the result the calculator will show you, this is going to be on the first quadrant. That's not what you want. You have to subtract pi so that you get to the argument that you have, which is this one over here, minus 2 pi over 3. If you do for this one, this is just going to be minus square root of 3 over 1. The calculator will show you minus pi over 3, and this is fine because it's already on the second quadrant, okay? And you don't have to do anything for any argument that lies on the first and the... I said second quadrant. This is not second quadrant. The second quadrant is this one. This is the fourth quadrant. Let me correct that very quickly. Okay, corrected. This is the fourth quadrant. Everything that lies on the first and the fourth quadrant, you don't have to perform any mathematical calculation to get the correct argument. So fourth quadrant, the result in a calculator is the one that you put. Okay, so final answer for this complex number, the modulus is 2, the argument is minus 2 pi over 3. For the other one, the argument is also true, sorry, the modulus is also true, and the argument is minus pi over 3. Then, show that the origin and the points representing the roots are the vertices of an equilateral triangle. For you to prove that you have an equilateral triangle, you either calculate the angles, and they shall be all 60 degrees, or you just measure the lengths of each side, and they should be all the same, okay? So imagine here a triangle. I didn't write it, okay? You know that the distance from the origin to the points, so this distance over here and this distance over here, we just calculated them, and they are both 2. If this distance is also 2, then it is equilateral. And just by looking at the diagram, you can see that it is, okay? What is the real part over here for this number? It's 1. For this one is minus 1, so this distance is 2. Or you can prove it just by doing the distance between 2 points, okay? So it's 1 minus minus 1 squared plus minus 3 minus minus 3, which is basically 0 squared, square root of the whole thing, and you have the result there, 2. All sides have length 2, so the triangle is equilateral. Last exam. Spring 2011, question paper 31. And the question is this one, question 8. The complex number u is defined by u equals 6 minus 3y over 1 plus 2y. Showing all u working, find the modulus u and show that the argument of u is minus pi over 2. This should be simple by now. You just need to know how to divide complex numbers. Okay, I just factorized this first, so things become a little bit easier. And then I multiply by a fraction composed numerator and denominator by the complex conjugate of that. Perform this multiplication. Eventually, you end up with this, which is just minus 3y, 3i, okay? So the modulus of this is obviously just 3. And what is the argument of any number that lies on the imaginary axis? If it is in the positive side, it's pi over 2. If it is in the negative side, is minus pi over 2. Is this angle over here, right? Okay. For complex numbers, z satisfying argument of z minus u equals pi over 4, find the least possible value of the modulus of z. Okay, what does this mean? Argument of z minus u is basically this. Z minus 3y, or just plus 3y. The point of reference is still that over here, which I just plotted here in an Argand diagram. All right. And you know that argument of this is pi over 4. So what does this mean? In relation to this reference point, the minus 3y, you will have an angle that makes an angle of pi over 4 in relation to a straight horizontal line that passes through this point. Okay, line parallel to the x-axis, and the argument is pi over 4. So the value of z shall be anywhere in a line that is along this. What do you want? You want the least possible modulus of z measured against the origin. So what is this? This is a horizontal, a straight line that is perpendicular to this one. And you can just use trigonometry from now on to figure out how big this is. For that, for you to know this, you need to know this side over here, because you already know that. This is 3. In order for you to know this side, the size of this side, you first need to know the size of this one. And for that, you also use Pythagoras theorem, because you know that this is 3. This is 3. By the way, how do you know that this is 3? This is pi over 4, so that's 45 degrees, right? This line over here will cross the real axis also at the same distance as that one, because this is 45 degrees. Make sense? So this is 3, this is 3, so you can get this bigger hypotenuse here, which I call capital H, which is 3 square root of 2. So how much is this? AL, I call this point L. AL is just going to be this divided by 2, right? This point L divides this hypotenuse into equal sides. OA is 3, so you can get OL. So 3 squared equals 3 square root of 2 over 2 squared plus OL squared. Just do the calculations and you have here the value of OL, 3 square root of 2 over 2. Okay? Actually, now that I think of it, you could also have used trigonometry in a different way. You know that this is pi over 4, so this is also pi over 4. And because of that, this line shall be the same length as that one. And once you get that, you can get automatically that. Anyway, as long as it is correct, any method is good enough. Where am I? Last one. For complex numbers, z satisfying z minus 1 plus I times u, modulus of that equals 1. Find the greatest possible value of modulus of z. Same approach. So let's just draw, first of all, calculate this. U is minus 3i, so eventually it becomes this. This is the point of reference, 3 minus 3y, so 3 minus 3y, the point is over there. And what does this mean? You should know this by now. This is, the point Z is on a circle with center 3 minus 3i and has radius 1. So here you have it. You want the highest possible modulus of Z, again measured against the origin. So what is this? This is this point over here, is the biggest it can get. And what is this length? Is going to be equal to this, which I called A, plus 1, right? So all we have to do, using just trigonometry, is to calculate A. And this is simple because you know that this is 3 and this is 3. So A is square root of 3 squared plus minus 3 squared, which is 3 square root of 2. So the greatest possible value of z is going to be this plus 1.